Hello, good morning. Today we are going to study about the deformation due to self-weight in a beam. So, draw the necessary diagram for this condition, and for this we have a fixed ceiling or fixed surface from where a beam or a rod is hanging. Here beam or bar, beam or bar, self-weight. Length is L, length is L. So, and this is the section having dy is length dy, and this from the free surface of the bar is the length y. And as we know that stress is equal to force by area, stress is equal to force by area, or we can also write it as P by A, and also strain is equal to change in length by length. Okay, this is strain. Now, as we know, the Young's modulus or modulus of elasticity E is equal to stress by strain, that is stress by strain. And now putting this value of stress and strain, we get P by A and strain delta L by L. So by L should be written as upper. Now we get from this equation we get E is equal to PL by A delta L. And now taking delta L, this change in length to the left side, we get change in length is equal to PL by A into E. This is an important equation for the stress and stress condition, strain and stress condition. Now we assume the area of this bar, the cross-sectional area of this bar as A. As here we have taken A, this is the cross-sectional area of this bar, and suppose the unit weight of this bar is gamma. Unit weight of this bar is gamma. This is unit weight. Unit weight. This is unit weight. Now, as we know from the definition of unit weight that it is equal to unit weight that is gamma is equal to weight upon volume. Weight upon volume. This implies weight by volume, and the volume equals area multiplied by the length. Okay, unit weight is equal to area multiplied by the length. And for this condition here we are taking here for this section or for this thin strip of the bar, the load applied is equal to the weight of this section of the bar, as because it is below this section, this section is below this strip, so the weight of this strip acts as an external force for this strip, and hence it will act as the P, that is the force, and hence we are taking its unit weight multiplied by the volume. So its unit weight multiplied by the volume is equal to this force, that is the force acting on this strip, the external force acting on this strip, that develops the stress and strain into this. So we write here gamma is equal to W by A into L, and here the length is equal to this Y. So now taking out W from this equation, we get W is equal to gamma A into Y. Now putting the value W into P, we get delta L is equal to gamma A into Y into length. Here we are talking about the change in length of this strip. Hence the length of this strip is dy. So here in place of L we write dy, that is dy by A into Y. Good, Y. Now solving this equation, we get here A get cancels and Y also get cancelled. Now putting the value of this W into the place of P, we get delta L is equal to P, and here P is equal to W, so gamma into A into Y into L. Here the L, we are taking the change in length of the strip, of this strip, hence we take it here the length of this strip is dy. So in place of L, we put this length, as we are taking the change in length of this strip only, na? So now dy. So in place of P, this is P, and in place of L we put dy divided by A multiplied by E. Hence here A get cancels. So we get delta L is equal to gamma by E into Y dy. So this is the change in length for this strip. This strip only. Now for getting the whole change in length, we have to integrate it in the between the limits 0 to L. From 0 to L. Here 0 to L. We have to integrate it from the limit 0 to L. So is equal to gamma upon E integration 0 to L Y dy. And this will give gamma upon E is equal to, here integration is equal to y square by 2, 0 to L. So on putting this limit, we get gamma by E into L square by 2. We finally get this. Now this is the change in length. So we can also write it as delta L is equal to 1 by 2 gamma L square by E. This is the equation for total elongation of the bar due to its self weight. Or in some books the unit weight of the bar, is also written as small w. That is, unit weight of the bar is also written as small w. So we can also write it this formula as delta L is equal to 1 by 2 W L square by E. So don't get confused through this symbol and this symbol. Both are same. We can use small w as unit weight of bar, or can also use gamma as the unit weight of bar. Hence delta L is equal to WL square by 2E. We can also edit the WL square by 2E. Hence this is proved. Thanks.